Hello children, how are you? I hope you all are happy and healthy. So tell me, what are we going to do today? We are going to talk about the Herons formula today. Do you know what is it used for? Okay, forget it. You tell me, what is the formula for area of a triangle? It's half into base into altitude. And why is it so? Do you know that? Would you like to know? Okay, then look here. Let's start from a rectangle. The area of a rectangle is length into breadth. So what will be the area of a parallelogram then? See, suppose I cut this part of this rectangle and then join it here. Then I will have a figure like this. Now this L will be equal to this L because this part has been cut from here and joined here. And this height, it will be equal to this B. So area of this parallelogram will be equal to L into this B, isn't it? Now let's have a look at the area of a triangle. That is the reason area of a parallelogram is base into altitude. This L has become the base of the parallelogram and this B has become the altitude. So area of the parallelogram is base into altitude. Now let's have a look at the area of a triangle. So here is a parallelogram. Now we know that area of this parallelogram is base into this altitude. Now suppose if I draw a line and join this diagonal. By joining these two vertices, I will get this diagonal. Now this diagonal is dividing the parallelogram in two equal parts, into triangular parts. Suppose this is A, this is B, C and D. So ABC is the first triangle and CDA is the second triangle. And we know that these two triangles will be equal in area. Why? We can cross check it by cutting it from this center. Also, we can use the theorem SSS. By SSS congruency rule, we will see that triangle ABC is congruent to triangle CDA. Thus, area of ABC will be equal to area of CDA. It means the area of triangle ABC will be half of the area of this parallelogram, which is ABC, D. So area of triangle ABC will be half into base into altitude. So now we know why the area of a triangle is half into base into altitude. So now let's move further. Now suppose we have a right angle triangle. So it's very easy to calculate its area because here the base will be this 5 centimeter and the altitude will be 12 centimeter. So the area will be half into base, that is 5, into altitude, that is 12. So here we will have 6 and the answer will be 30 centimeters square because all the measurements are in centimeter. Now suppose this triangle is made like this. Dimensions are still the same. This is 5 centimeter. This is 12 centimeter and this is 13 centimeter. We have simply made the same triangle to lie down like this. Now, will it make any difference in the area? No, the area will be still the same. It will be half into base, which is 12 now, into altitude, which is 5 now. So here again we get 30 centimeters square. That was easy. Let's see the next triangle now. Now suppose we have an equilateral triangle. That is a triangle whose all the three sides are equal. It is 10 centimeter here. So how can we find out its area? We need the base and the altitude. So if I draw an angle of 90 degrees here from this vertex, then this line will obviously divide this base into two equal parts. You can also prove this with the help of RHS theorem. So it means 5 centimeter and here also 5 centimeter. These two smaller parts are of 5 centimeters each. Now, how can we calculate the altitude? We know that this is the angle of 90 degrees. So here this length, suppose A, B, C and D here. Here BD is 5 centimeters, AB is 10 centimeters. So we need to find out AD. We can use the Pythagoras theorem here. According to this, AD square will be equal to AB square minus BD square. Now putting the values, AD square will be equal to 10 square minus 5 square. So AD square will be equal to 100 minus 25, which is 75. AD square is 75. So AD will be 75 square root. Now if we make the prime factors of 75, we will have 3 into 5 into 5. To find out the square root, we will have to bring 1 5 out of this pair. So here we will have 5 under root 3 centimeters. So this will be the length of AD. AD is equal to 5 under root 3 centimeters. Now we know the base, which is 10 centimeter, also the altitude, which has come to 5 under root 3 centimeters. So now these two values can be used to find out its area. Let's move to the next triangle now. Now suppose we have a triangle which is isosceles, that is the one that has two equal sides. Here AB is equal to AC equals to 5 centimeter and BC is 6 centimeter. So how can we find out its area? Again we will need the altitude. Can we have it? By again drawing the altitude from point A to BC. Here the angle of 90 degrees. It will divide the base in two equal parts. Again this can be cross-checked with the help of RHS axiom. So here BD, suppose this is D, so BD will be equal to DC equal to 3 centimeter. Now in this triangle ABD, we have BD equals to 3 centimeter and AB equals to 5 centimeter. Using the Pythagoras theorem, we can have the length of AD. And if we look carefully, we will see that it is also a Pythagorean triplet. So here the length of AD will be 4 centimeters. You can cross-check it by actual calculation. Now, when we know the altitude, we can easily have the area of the triangle by using the formula half into base into altitude. That is half into base here is 6 and altitude is 4. So the answer will be 12 centimeter squares. Now let's have a look at the scalene triangle. What can we do with that? So here is a scalene triangle. All the sides are of different length. So what can we do here? To find out the area of such a triangle, we have the Herons formula. We call it Herons formula because it was discovered by a mathematician with this name, Herons. He has written many books on mensuration and in one of his books he has mentioned this formula. Let's see what it says. For this, first we need to calculate the semi-perimeter of a triangle. Semi-perimeter. For that, we will have to add all the sides and then divide it by 2. Here, the length of first side is 12, then 16 and then 20. We need to add them all and divide by 2. Adding this all, we will get 48 and 48 upon 2 will give us 24 centimeters. So its semi-perimeter is 24 centimeters. Now the formula for the area is area of triangle will be S into S minus A into S minus B into S minus C whole square root. Here S is the semi-perimeter and A, B, C are the different sides of the triangle. Now putting these values here, 24 multiply by 24 minus 12, then 24 minus 20, then 24 minus 16. The order of the sides doesn't matter because they all are getting multiplied only. So here we will have 24 multiply by 24 minus 12 is 12. 24 minus 20 is 4. And 24 minus 16 is 8. Now, to find out the square root, we can simply find out the prime factors of all these numbers here only. And after that, we will take out one number from each pair of 2. So, 24 factorized will give us 2 into 2 into 2 into 3. 3 2s are 6, 6 2s are 12 and 12 2s are 24. For 12, we can write 3 into 2 into 2. For 4, 2 into 2, and for 8, 2 into 2 into 2. Square root. Now we just need to take out 1 out of each pair. 2 out of these 2, 1 more. From these we'll have a 3, again a 2, again a 2, and again a 2. Now, multiplication of all these factors will give us the area. 2 2s are 4, 4 3s are 12, 12 2s are 24, 24 2s are 48 and 48 2s are 96. So, the area of the triangle will be 96 centimeter squares. To see this, let's have a look at the first question of exercise 12.1 of your book. The question is, a traffic sign board indicating school ahead is an equilateral triangle with side A. Find the area of the signal board using Herons formula. If its perimeter is 180 cm, what will be the area of the signal board? So suppose here is the traffic signal board, the equilateral triangle. The side of the triangle is A. Now we need to find out its area by using Herons formula. For that, first we will need the semi-perimeter. That will be equal to A plus A plus A upon 2. That is 3A upon 2. We can also write it as 1.5A. Now this is the semi-perimeter. To find out area, we will write S into S minus A into S minus B into S minus C. In this case, A, B, C all are equal. So putting these values, we will have 1.5A multiplied by 1.5A minus A multiplied by 1.5A minus A again multiplied by 1.5A minus A square root. Now solving this, we will have 1.5A multiplied by 1.5A minus A will give us 0.5A. Same here 0.5A and here again 0.5A square root. Now making the factors of 1.5A, we can write 3 into 0.5A. This multiplied by 0.5A multiplied by 0.5A multiplied by 0.5A square root. Now taking out 1 out of these pairs, we will have 0.5A multiplied by 0.5A multiplied by under root 3. So it will give us 0.25A square multiplied by under root 3. Now if we remove this decimal, we will have 25 upon 100 A square into under root 3. It can be written as 1 upon 4 A square under root 3. So now we know that area of an equilateral triangle is under root 3 upon 4 A square. This can be written like this also. Now we need to find out the actual area of the board if the perimeter of the board is 180 centimeters. If perimeter is 180 centimeters, then what will be the length of the side? We know that perimeter of an equilateral triangle is 3A. If 3A is equal to 180 centimeters, then A will be 180 upon 3, that is 60 centimeters. So length of A is 60 centimeters. Now to find out the area, we simply need to put this value in this formula. So area will be under root 3 upon 4 into A square, that is 60 multiplied by 60. Now this will give us, so here we have 3 3s are 9, so 900 and under root 3 centimeters squares. That's the area of this triangle. Now let's have a look at the next question. The triangular side walls of a flyover have been used for advertisements. The sides of the walls are 122 meters, 22 meters and 122 meters. See figure 12.9. The advertisements yield an earning of rupees 5,000 per meter square per year. A company hired one of its walls for 3 months. How much rent did it pay? So suppose this is the side wall of the flyover. Its dimensions are 120 meters, 122 meters and 22 meters. Now it yields an earning of 5,000 per meter square per year. We must notice that the rate here is given per year, whereas that company has hired the wall for 3 months only. So for the answer, we will have to multiply the rupees with 3 upon 12. Because the answer will be meant for 12 months. To make it 3 months, we will have to multiply the same with 3 upon 12. Let's see how. First of all, we will have to calculate the area of the wall. Do we need to use the Herons formula here? We know that this is the wall. So this must be straight one. So this must be an angle of 90 degrees. So we can use the other formula also. But as the chapter's name is Herons formula, so here we will use the Herons formula only. For that, we will need the semi-perimeter first. S will be equal to A plus B plus C upon 2. That is 122 plus 120 plus 22 upon 2. It will give us 4, then 6, then 2. 264 upon 2. It is equal to 132. So semi-perimeter is 132. Now for area, let's use the Herons formula. That is, area of triangle is equal to S into S minus A into S minus B into S minus C, square root. Now putting the values, we will have 132 multiplied by 132 minus 122 multiplied by 132 minus 120 multiplied by 132 minus 22, square root. So 132 multiplied by 132 minus 122 is 10, 132 minus 20 is 12 and 132 minus 22 is 110, square root. Now, the prime factors of 132 will be 2 into 3 into 2 into 11. 10 can be written as 2 into 5. For 12, we can write 2 into 2 into 3. And for 110, we can write 11 into 2 into 5 under the root. Now, making the pairs of 2, 1 2 out of these and 1 3, 1 time 11, 2 again, 5 and 2 again. Now multiplication of these numbers will give us the answer. 3 2s are 6, 11 6 are 66, 66 into 2 is 132 and multiply by 10. It will give us 1320 meter square. That's the area of the wall. Now it is yielding 5,000 rupees per meter square. So we need to multiply it by 5,000 and then for 3 months we will have to multiply this by 3 upon 12. Let's do it. 1 meter square gives a yield of rupees 5,000. So 1,320 meter squares will yield 1,320 multiplied by 5,000 multiplied by 3 upon 12 because we need to find the answer for 3 months only. Now dividing it, we will have it will give us 110, and multiplying this all, we will have 55, 1, 2, 3, 4 times 0 into 3. It will give us 5 3s are 15, 165 and then 4 zeros. That means 16,50,000 rupees. That's the answer. Now, question number 4 is, find the area of a triangle, two sides of which are 18 centimeter and 10 centimeter, and the perimeter is 42 centimeters. Now, to find the area of this triangle, we need to know the third side, because third side is not given, but perimeter is given 42 centimeters. So, how can we do that? If this is A, this is B and this is C, then we can write that 18 plus 10 plus C is equal to 42, because 42 is the perimeter, or 28 plus C equals to 42, and C is equal to 42 minus 28, that is 4 and 1, that is 14 centimeters. Now we know all the three sides of the triangle. So with the help of Herons formula, we can easily calculate its area. So let's move to the next question. Fifth question is, sides of a triangle are in the ratio of 12, ratio 17, ratio 25, and its perimeter is 540 centimeters. Find its area. So the ratio of the sides of this triangle are given as 12, ratio 17, ratio 25. Now suppose these sides are 12x, 17x and 25x. Now the perimeter of the triangle is given 540 centimeters. So 12x plus 17x plus 25x will be equal to 540 centimeters, because that's the perimeter. Now when we will add these all, we will have 54x equals to 540, and the value of x will be 540 upon 54, that is 10. So x is equal to 10. So have we got our sides? Not yet. This is the value of x. For the sides, we will have to multiply 12 by 10 for the first side. It will give us 120 centimeters. 17 multiplied by 10 will give us 170 centimeters. That's the second side. And 25 multiplied by 10 will give us 250 centimeters. That's the third side. Now that we know all the sides of the triangle, so we can easily calculate the area with the help of Herons formula. So let's move to the next question. Question number 6. An isosceles triangle has perimeter 30 centimeter and each of the equal sides is 12 centimeter. Find the area of the triangle. So each of the equal side is 12 centimeter. So what will be the length of the third side? Again 12 plus 12 plus C will be equal to 30 centimeter, because perimeter is given 30 centimeters. So 24 plus C is 30 and C will be 30 minus 24, that is 6 centimeters. So this length is 6 centimeter. Now we know all the three sides of the triangle, so we can easily calculate the area. So let's move further. Exercise 12.2, question number 1. A park in the shape of a quadrilateral ABCD has angle C equals to 90 degrees, AB is equal to 9 meters, BC is equal to 12 meters, CD is equal to 5 meter and AD is equal to 8 meter. How much area does it occupy? So here is the rough diagram of the quadrilateral. We know that angle C here is of 90 degrees. Now, can we use this angle to find out the area of the quadrilateral? What can be done? See, here angle C is 90 degrees, length of CD is 5 meters and length of BC is 12 meters. If I join the diagonal BD, then we have got a triangle BDC, which is a right angle triangle. So can we have the area of this triangle? Yes, by using the formula half into base into altitude. That will give us half into 5 into 12. That is 30 centimeters square. Now we need to find out the area of triangle ABD. For that we will have to know the length of BD. Now this is a right angle triangle. If we use the Pythagoras theorem here, then we can easily find out the length of BD, which is the hypotenuse. By looking at it, we can also find out that this is also a Pythagorean triplet, 5, 12 and 13. So length of the hypotenuse will be 13. BD will be equal to 13 centimeter. You can cross check it by actual calculation. Now, when we know the three sides of this triangle, then by making the use of Herons formula, we can easily calculate the area. And for the area of whole quadrilateral, we will have to simply add the area of these two triangles. First is 30 centimeter squares and the next one you will be calculating with Herons formula. Third question is, Radha made a picture of an aeroplane with colored paper as shown in figure 12.15. Find the total area of the paper used. So here is the aeroplane that Radha has made. Now we need to calculate the area of the total paper used in this. For ease of calculation, it has been divided into 5 parts. See the first part, second, third, fourth and fifth. We will calculate the area of all these parts separately. For the first one, it is an isosceles triangle with two sides equal to length 5 cm and this one is equal to 1 cm. So we know all the three sides, 5, 5 and 1. So with the help of Herons formula, we can easily calculate the area. Now look at the second part. It is in the shape of a rectangle. The length of the rectangle is 6.5 centimeters and the breadth is 1 centimeter. So area can be easily calculated. Now look at the third part. It looks like a trapezium. Here this length is 1 centimeter and this length is 2 centimeters. So how can we calculate the area of this part? If I draw one line parallel to this one here, it will also be of 1 centimeter in length. Similarly, if I draw this line parallel to this one, it will also be 1 centimeter. And this point will be the midpoint of this line. So this part will also be 1 centimeter. Thus we have got three triangles. The side of each one of these is 1 centimeter only. So now we can easily calculate their area because all the three are equilateral triangle. We can use the formula under root 3 upon 4a square. We just saw that area of an equilateral triangle is under root 3 upon 4a square. So we will calculate the area of one triangle and multiply it by 3. So we will have the area of this part. Now looking at the fourth and fifth part, they both are equal. So this length is 6 centimeters and this is 1.5 centimeters. We know that this angle will be of 90 degrees. So if this is the base and this is the altitude, then the area of this right angle triangle can be easily calculated with the formula half into base into altitude. And then that area will be multiplied by 2 to get the area of this part also because these two parts are equal in area. Thus, we have calculated the area of all the 5 parts. So, by adding the area of all the parts, we will get the area of the total paper used. Moving to the next question, question number 5. A rhombus-shaped field has green grass for 18 cows to graze. If each side of the rhombus is 30 meters and its longer diagonal is 48 meters, how much area of grass field will each cow be getting? So here is that rhombus-shaped field. By simply looking at the rhombus, we can easily tell that to find out the area of the field, we just need to find out the area of this triangle and then multiply it by 2 because both the triangles are equal, that is congruent. So we know all the three sides of this triangle, 30, 30 and 48. So we can easily calculate the area and then we will multiply it by 2 to get the area of the field. Now this whole area is available to 18 cows. So the field or the area of the field that one cow will get, that we will have to calculate by dividing the area of this field by 18. So the area of rhombus divided by 18. It will give us the area that each cow will get to graze. Question number 8. A floral design on a floor is made up of 16 tiles which are triangular. The sides of the triangle being 9 cm, 28 cm and 35 cm. Find the cost of polishing the tiles at the rate of 50 paisa per centimeter square. So, the dimensions of one triangle are 9 cm into 28 cm into 35 cm. These are the three sides of the triangle. So, with the help of these, we can easily calculate the area of the triangle. And then we will multiply that area with 16 because there are 16 such tiles. Now, cost of polishing 1 centimeter square is 50 paisa, that is 1 upon 2 rupees. So, to find out the total cost, we will multiply the area of 16 tiles with 1 upon 2. That will give us the answer in rupees. So, children, in this chapter, you have studied the following points. Area of a triangle with its sides as A, B and C is calculated by using Herons formula, stated as area of triangle is equal to S multiplied by S minus A multiplied by S minus B multiplied by S minus C whole square root, where S is equal to A plus B plus C upon 2. And area of a quadrilateral whose sides and one diagonal are given can be calculated by dividing the quadrilateral into two triangles and using the Herons formula. So children, this was your chapter Herons formula. Now you can easily do all the questions of both the exercises of this chapter. So keep practicing and we will meet in the next chapter now. Thank you. Have a nice day.